You have to be very careful. We talked about this before. I believe I used this analogy. I said, okay, let's say you're going to Papa John's Pizza. You can buy a 10-inch pizza for $10, or you can buy a 20-inch pizza for $30. And I said, well, which one is the better deal? And most people right off the bat will say, well, this one's twice as big, but it costs more than twice as much. Okay, most people fall into that. And that's not true, because you can't do, when you talk about area, which is what you'd have to find which one's the bigger one, area is a product of two-dimensional changes. Okay, and I'm going to do a square just because it's easier to figure out the area of a square. Let's say I have a square that's 10 inches on the side, and I have another square that's what we think is doubled, and it's 20 inches on the side. Same thing. What is the area of the littler pizza? Peter? 100 inches squared. What's the area of this one? 20 times 20 is, Peter, 400 inches squared. In reality, this pizza is 4 times bigger, as this would be 4 times bigger. So if you're using this $10 as your base price, this one really should cost $40, not $30. This is the better deal. And the reason for that is, yes, you doubled the dimension, but you actually, area is a product of two dimensions, and you doubled both of them. Okay, not only did I double this one 10 to make it 20, but I doubled this other one. So really what I did is I double. And when you double, you get 4 times bigger. So you have to be, I don't know if that made any sense to you, but you have to be very careful when they ask you, when you change dimensions, what happens to the area. Because if you double the area, it's really this. What's my scale factor to go from 10 to 20? My scale factor is 2. The change in the area is always going to be the scale factor squared. Okay? Change in the area. When you double the dimensions, the area gets squared, whatever you did. If I went 3 times bigger, let's say I went from 10 inches to 30 inches on the side. What's my scale factor from 10 to 30? 3. If I square that, that's how many times bigger this is area-wise than what I started with. So this is going to be 9 times bigger. This will be 900 square inches. 100 times that, 100 times 9 is 100. So I'm just saying you got to be careful. That really has nothing to do with what we're talking about today. But I thought I'd remove that. No, it has a little bit. So write down this problem here. One square is 50% larger than another square. One square is 50% larger than another square. Three questions I'm going to ask you. The perimeter of the larger is what percent the perimeter of the smaller? Okay. Perimeter, not area, of the larger is what percent of the smaller? Letter B says the area of the larger is what? Area of larger is what percent of the smaller? And then letter C is, oh, no, I don't need number C. It's not that. So what do you suppose, by the way, even if you don't understand this, I expect you at least to attempt this part of things. There are some things you can do to attempt this. First thing you suppose we probably have to do, Savannah Vickery, is draw the square. So I need how big do I draw the square? What is the size of the small square, Evan?
The size of the
Yeah.
square.
What's it tell me the dimensions of the small square are?
Like any dimensions.
So does it tell me the dimensions? And if it doesn't, that should make you smile because you get to make up your own dimension. Which means you can pick easy numbers to work with, and that's what I would do. If I were given this one, I'm starting with the square and then making one that's 50% larger than it. I would probably start with, I wouldn't start with 1 because you might end up with decimals, but I might start with 10. If I start, oh, it's not right. If I start with a 10 by 10 square, and I make another one whose dimensions are 50% larger, how big's my next one gonna be? And that's where it gets a little goofier. What's 50% of 10? So my next one is 50% larger, so in view its 10, it's going to be 15 by 15. Wonderful. And you can pick whatever you want. If you wanted to pick 100, you could pick 100. Okay, but I picked 10 because 10 is a relatively easy subject. Kids, Mrs. Stone's having issues with her DVR/whatever. Oh, was it just a hard reboot? Huh?
No, I just went to CNN quick to see the work too, because that was the, whatever, I went back to channel 2.
So maybe all things run through CNN.
I don't know, maybe I just had to reconfigure that. Oh wait, I'm not in HD. I'm not in HD. You know those real close.
I do, never looked at it.
You know, well, I can't.
10
figure
days
out
of
how-
counting, man.
I can't figure out how to, she said my old son was there, but I can't see it. I'd rather not. No, I can find it.
Hold on to that. Okay, so good, we've got our 2 squares, everybody's happy. So we're talking about, we need to find perimeters and areas of both of them. Should be a piece of cake. Perimeter of the small square is 40, whatever it was, millimeters, centimeters, something, doesn't really matter. Let's just do inches because I like doing that. And the perimeter of the big one is 60. Good. You're doing better than I thought. Now, here's where part of it goes wrong. The perimeter of the larger is what percent of the smaller? That sometimes throws people off. Does that throw you off? Do you have any idea what to do with that?
No.
Okay. Here's what you do when the percent, on a problem like this, when the percent throws you off, think about it as not percent, but say what fraction. Substitute percent with fraction, and then whatever fraction you get, change it to percent. So if I asked you, what the larger one is what fraction of the smaller? Larger over smaller. Larger over smaller. That's what fraction it is. I just need, instead of fraction, they ask me for percent. Okay? Did I do that right? Did I do that backwards? Yeah, I guess that's right. And you get what? What'd somebody say? Reduce this now and you get 3/2, which is 150%. What percent of the smaller? Right on, Ranger? Okay. What about area? What's the area of the small one?
100.
Area of the big one, 15 times 15, anybody?
Mid.
Okay. And the same thing is true with that. The area of the larger is what percent of the smaller one? Again, don't think about percents, think about fraction. What fraction would you use? 225 over 100, and that's an easy one to turn to a percent because it is. Oh no. So what percent is that? Yeah, it's 225 because percent means over 100 and it already is over 100. How's that? Does that not make sense?
No.
I know it does. Alright, here comes another one, tougher still. Now, this one, The towel shrunk 10% when it was washed. The towel, has any of your parents ever shrunk any of your clothing?
No, there's no ink on.
Someone missed my socks.
The towel shrunk 10% when it was washed. The area of the towel was reduced by what percent? This one gets tougher still. The area of the towel was reduced by what percent? Okay. Once again, how big is my towel? You don't know. So, pick. It doesn't really matter. It's going to be the same answer whether you pick 1,000,000, 1,000, or whatever. So, I will probably pick what?
10.
I'm going to pick 10 again, just because it's that much easier. My towel, and again, I'll make it a square. You could make it a rectangle, but I'm just going to say it doesn't matter. So, it's going to be a 10 by 10 towel. It was reduced by 10%, which means it became smaller by 10%. So, what is 10% of 10?
I don't know.
10%, 0.1 times 10 is 1. So it was reduced by 1. So my new towel is now a new size of 9 by 9. Okay, got it? Now this one gets a little dicier than the last one, but I want you to think about it like this. If they ask you about reduced fractions, great, that's just what I wanted. No. If they ask you for reduced fractions or increased fractions, I would make that fraction box, or ratio or percent box. That's probably the best way to do it, reduce in percents. Because remember when we talk about reducing in percents, you start with the original, which is 100%. You then reduce it by something, and you get the final one, correct? Remember that whole like mark up, mark down thing? Christine, will you close that door, please? Here's my actual thing. Well, what was my original square? What was the area of the original one? 100. Can you see that? What was my new one? Now, is that my final one, or is that how much it was reduced by? That's my final one. Oh, great. So by how much was it reduced? What do I want to know? The area of the towel was reduced by what amount? Here's my one I don't know. I want to know how much it was reduced by. And again, this one's not going to be very difficult. Why? Because I chose some nice numbers to start off with. What is my proportion, my ratio? 100 over n equals 100 over 19. Don't think too hard on this one. What number goes there? How do I go from 100 to 100? Multiply by 1. 19 times 1. This thing was reduced by 19%. 9%. Yep.
Well, could you also just flip the 19 and 100, put the 19 on top?
But you have to flip this one too. Again, it just so happened to work out that way because we picked those nice numbers. I can tell you want a problem to try on your own. Oh yeah, no, let's do one more, that's volume. The dimensions of a cube are increased by 100%. By what percent is the volume increased? Dimensions. We did talk about volume, so this will be good. Of a cube, really? Oh, I always like it when it says that.
Yay.
Wait, you're cheering because the thing crashed?
Yes.
No.
What kind of people are you?
We're
3, 2, 1.
Don't worry. I mean, work.
You're gonna make me go to the blackboard.
Yeah. Old fashioned.
I
Work. The blackboard can crash too.
We could just.
I don't see it coming.
Crack in half.
Yeah.
Yay.
Dimensions. It's not any better.
Yay.
Of a cube increased by 100%. By how much is its volume increased? By how much is the volume increased? Now notice this didn't say what percent of or whatever it is, it's by how much was the volume increased, means at the end, we're gonna have to do another one of those percent tables. Original plus the increase equals the final, that's what we'll get to in the end. But first we need to sketch our cube. Doesn't tell us the dimensions of the cube, so we pick, I would go with 10. You again, you know, in this case here, you could go with, you think about what you're gonna do to 10, you're increasing it by 100, so you could pick 1 even, it doesn't really matter, but let's go 10.
Pick one.
You wanna pick 1?
Yeah.
So 1 inch by 1 inch by 1 inch, what's 100% of 1? So it increased by 1, so my new cube is 2 by 2 by 2 by 2. And the volumes then, what's 1 times 1 times 1? The volume of this equals 1 cubic whatever inch. And the volume of this one, 2 times 2 times 2 is 8 cubic inches. Now you might think you know the answer to this. The question asks you by 100%. Dimensions of a cube increased by 100%. By how much is the volume increased? By how much is the volume increased? If you were telling me the answer to that, what do you think the answer would be?
8.
What's percent? 8 is not a percent, 8 is a number. What is 8 as a percent? 800%. You might think 800% is the answer, but if you do it like I talked to you about, here's what you have to think. Do your box. I have, this is my percent. I have my original thing, and then here's my, plus my increase equals my final. Okay, my original percent is 100. This is the actual object. What was my original volume of my original thing? Volume of this one was 1. What was my final? 8. Okay. What, so how much did it increase? What question did they ask me? Did they ask me how much the increase was, or did they ask me how much, what the final was? How much is the volume increased? They want this one. So maybe you can see it, it is 100 over what number is 1 over 7? Correct, 1 times 100, 7 times 100. The answer is really 700. It's a 700% increase. Because it went up 700%. Okay, it started out being this 100, ended up at, or 1 ended up at 8, so it's, so you have to be a little careful and take a little bit of time there. That was exciting, wasn't it? Right now, children, I'm going to give you, I do want to still do another one.